Okay, today we are inviting Dr. Khan for an interview, a talk about big data and data mining and big data management and analytics. First, I want to start asking, can you briefly introduce yourself to us? What are your research topics? Where are you studying and so on?
Thank you, Dr. Sadi and Shekhar. My name is Professor Latifur Khan. I'm a professor at University of Texas at Dallas in Computer Science Department. Currently, I'm working on, and I work in big data management and analytics area. And before that, coming to this research position as a research scientist, and I finished my PhD from University of Southern California at USC in 2000, and then I joined at UTD as the University of Texas at Dallas as assistant professor. And then last couple of years I started to work on big data management and analytics area. So I think might be a very hot topic nowadays. So everybody wants to do the big data. So I will talk about some of this stuff.
Okay, thank you very much. Thank you. And let's start with our first question, an introduction question. How would you define big data, the topic of big data? How would you define it?
The definition of big data is a little bit ambiguous because misnomer, and there is no standard definition, but you can think about when the data has a bunch of V's, they call it, if it is a very large in volume, and that might be one characteristics. Another characteristics is data will come with a very high velocity, with a high speed. And then the third characteristics you can think about volume, velocity, varieties. Data will not be only structured, it can be unstructured or semi-structured. Like in a typical scenario, most of the Oracle database management system or those relational database management system, they always think about data will come as a bunch of tables or relations. But in this case, data can be not only tabular form, it can be like a bunch of text documents or short messages like you post in the Facebook or you send in the Twitter as a messages. Those can be a part of the big data, can be a part of the big data. So when you have a data which will be very huge or large volume and which comes with a very high speed,
change in speed.
Yeah, and then also it can be not only structured, it can be unstructured or semi-structured. That called varieties. And and there is other ways you can think about varieties. Veracities, that means data may be erroneous or may not be complete. So in that case, when you extract knowledge or patterns, it may not be give you the right answer. So you have to deal with the uncertainty, those type of things. So when you have this type of V's, at least a couple of them present in a certain data, then you can think about data will be known as a big data. So think about in the Facebook context, people are posting their messages and so on, and some of the users are reading their messages, and in the Facebook context, is not only one user is using the system, millions or more than millions of users are using that system, and also they're using the system means they're posting the messages and they're also reading it and so on. So it produces a very large amount of data over time. So the
volume is big.
Yeah, it's basically big data.
And so the volume is big in Facebook, and also the velocity is big, right? It's
right. Yeah. Many people are posting the messages within a very short time.
And we cannot rely on this data also.
Right. So it might be unstructured. It's a bunch of text text messages, short messages, and furthermore, it will be and whenever you user post the messages, some of them might be incomplete, maybe erroneous, and so on. When you try to extract some patterns or knowledge from there, that may not be the 100% correct.
So, what about our daily life? How the big data studies are shaping our daily life? How they are affecting us?
Oh, the big data is a very popular topic. The reason is there are potential lot of applications maybe we can come up with. For example, think about in a real life scenario. Let's say you are in Istanbul in a particular district, and with your cell phone and you want to know what is the nearby restaurants, and not only nearby restaurant, you want to know is there any promotion going on. Say if you can get a coupon, you might be interested to go there. So in this case, a couple of things the framework or the system needs to do. One, system needs to identify your exact latitude and longitude, and then based on the latitude or longitude, the system also needs to figure out what is the nearby restaurant. Once we have the nearby restaurant, then the advertisement industry needs to, or advertiser needs to figure out what coupons he wants to send. So all of this needs to be done in real time. If the system figures out after 2-3 hours that you are at this location and this might be the right coupon to send you, then that coupon may not be valid for that particular users. Furthermore, in healthcare, think about a particular patient is wearing a bunch of sensors. That means it captures the blood pressure, it captures the temperatures, those type of things. And all on a sudden, patient has a heart attack. So sensor should be able to capture that heart attack or the irregular heartbeat patterns in real time and send it to the monitoring system, so that there will be a alarm will be raised and sent to the doctors or nurse. They can come immediately and pay the attention to the patient. The main reason here is we need to do all of this in a real-time basis.
So all the data is collected and processed for all purposes, like marketing, healthcare.
Right, and then and some application may require very real-time attention, and some may need near real-time, some may need offline processing. Like what you in case of think about when you go to the grocery store or any shopping mall, you do some transaction or purchase, and from there we can, and offline we can generate a bunch of users' profile or interest, and next time the system can send a recommendation by saying that these are the news you may like it. Let's say in the YouTube, a particular user frequently watches a soccer game or football game. Then the system should recommend for that particular user some soccer game, new soccer game or something.
So they are collecting all the information related to all the people, and they process it for the use of these people. Yeah. But this is also scary on the other hand, I think. In all the science fiction movies, they are using this as a privacy threat for the people.
Right, yeah. So privacy will be an issue. Some cases user privacy might be violated. So that's why some companies are anonymizing this data and release it to the public.
For the public use?
Yeah.
Okay. So one of the disadvantages of big data is, I think, the privacy, right?
Yeah, privacy is the problem. So if you anonymize it, then if you want to, from this public data, I will need to say do some mining or pattern extraction. In that case, that might not be 100% correct or 100% accurate due to the anonymization.
And what are the challenges in this area, the big data studies?
Big data has two different components. One is called data management, big data management. Another one is the analytics part. And there are a lot of good technologies are developed for the management area, like already know that Hadoop, MapReduce, these are the NoSQL system. Then new product came called Apache Spark, which is an in-memory database which is faster than Hadoop, MapReduce, and it has a real-time analytics processing capability and so on. So in terms of the data management, I think that we are at a stage where we can process very large data in a distributed manner over the commodity hardware. So that's not an issue. But when it comes to analytics, the management part, what does it do? They store the data. And when the query comes, you can, based on your query, you can retrieve a portion of the data or a segment of data very quickly using that distributed system like Hadoop, MapReduce, or Spark. And now you want to run analytics algorithm. And most of the analytics algorithm heavily relies on the data mining approach or machine learning approach. The idea there is we assume that we do a lot of prediction. Let's say if you know that a particular customer buys a certain number of products in the past, then you can recommend similar products to that customer. So this type of system or recommendation or prediction, it needs in data mining area a lot of supervision or supervised training data. So the problem is in the prediction or classification case when sometimes the prediction might not be correct. So if the prediction is not correct, then it will be user might be annoyed. Think about in a security domain, when you do a intrusion detection system, if your system frequently says that there is an attack happens or intrusion happens, then that will be and most of the cases this will be a false alarm. So this will be an annoying situation. In future, people may not like it, customer may not like it to use that system at all. So this false alarm is one problem, or and another problem is in big data domain, we are not dealing with only on the structured data, we are dealing with the semi-structured, unstructured, those type of data. So, and basically we are dealing with a complex scenario. So how do you do the information integration? That might not be a trivial task. And we are getting data from multiple sources, and each source has its own definition, own schema, and so on. Those reconciliation may create problems. So at each step, will generate a lot of errors, and then those errors will be propagated at the end when you do the classical data mining or machine learning. And then another requirements in some cases, some application may require real-time analytics, real-time processing. If you want the example I gave you, healthcare or say mobile phone, you want to get the coupon based on your current location. If you process this large amount of data and give the recommendation after 2-3 hours, not within a second, those recommendations may not be valid or outdated. So these are the requirements, our major challenges still we are facing.
Okay, thank you. And what do you suggest for a person who wants to study in big data? How to start with big data? Which technologies to prefer? There are lots of technologies like Hadoop, Spark, MOA, MOA, other things coming up, also new technologies, and some commercial technologies. Not all of them are open source, but some of them are commercial. Which technologies do you suggest for starting with?
Hadoop, in the big data area for management part, big data management area, there are a lot of open source products out there, what we mentioned, for example, Hadoop and MapReduce, which is widely used NoSQL type of system. And then there is a other system, Spark, which is also open source. And there are a lot of online videos are available about those. So I recommend those who are interested about big data management, they should watch those videos, and they have a very good documentation about those products, and they can go through those materials and learn themselves. And also in terms of analytics, there are some framework we call MOA, and MOA is morely in a centralized based on a particular machine learning or data mining over the stream data, but it focuses on a particular one single machine. But they have developed now a system which deals with the parallel processing and so on. They call it that based on, I think, Storm technology and so on. But there is a Spark has a component called stream mining framework is already there, and there is some data analytics based on Spark or Hadoop MapReduce called Mahout. So those are the technology researcher can use. And then on top of it, there nowadays R is widely used in the industry also, but that's again non-parallel solution. In other words, it can handle a certain amount of data, but now they are working on a parallel version or distributed version. There are some tools or plugin available on top of R that you can add there and do the parallel processing. So that will give you basically address those scalability issues. So those who are interested in the big data and analytics area, I recommend them to go through Hadoop, MapReduce, and Spark. And in analytics area, in a nutshell, I can say they should focus on R, and then R's a parallel version and so on. R or Matlab, and because analytics part in future, I think uh, data gathering or gathering is a problem has been addressed quite well. Now the problem is with the analytics part, and again analytics part, there are a lot of tools are there, but most of the tools work in a centralized manner or in a single machine, but they're trying to improve it or parallelize it. So Mahout might be a good choice to take a look. And if somebody has a statistical background or math background, I think they can easily move to this area. It's not a big deal. They don't need to do that much coding, as long as if they know MATLAB type programming or coding, then they can easily learn those machine learning or data mining technology and then use those tools and identify patterns or useful knowledge. So that might be very useful for decision makers or business intelligence purpose.
Okay, thank you. So, also you are interested in stream mining, data stream mining or stream data mining. So, what is the relation between big data and data stream mining?
Yeah, so big data, I think I told you that data will be very large, comes with very high speed and so on. But most of the, when it comes with a very high speed, think about it, you need to consume that data because the production rate is very high. You need to consume it at the similar rate. If you cannot cope with that, then the data might be dropped in your system. So for example, think about in the LinkedIn case, not LinkedIn, sorry, Twitter case, people are sending a lot of short messages, 140 characters and so on. So now they need to capture this data in real time and make some decision or make or identify what is the common patterns for a particular window, those type of things they need to do it. So, or calculate some sort of average or aggregate information. So for that, the real-time processing is required, but that real-time processing will be done real-time processing will be done over the string. And Hadoop MapReduce is good for batch processing of the data. That means when you have a data comes, you can keep as a big chunk and then do processing and so on. But when continuously coming, then Hadoop MapReduce may not be able to deal with that easily. So for that, in the data, what is the not LinkedIn, the Twitter developed a technique called they use Storm technology. So they have first they put the data in a buffer and then pass it to this Storm. Storm has some bunch of internal system where they can handle this real-time data. And Spark has a facility to handle this real-time or streaming data. And once you handle this streaming data, you need to make sure that you need to infer some knowledges. And keep in mind that characteristics of data will be changing frequently over time. So if you, let's say, if you do some prediction over the stream, and you cannot rely on the prediction is, let's say you build a user profile and next time some new products come, you want to recommend. But user test or interest might be changed, maybe change over time. So in that case, you need to continuously update the user profile. So in this case, you will basically do window by window processing and captures the user profile and then fuse it together, and then some of the user interest might be dropped, new user interest maybe evolve over time, those type of things we need to deal with this. So this brought basically what I'm trying to say here, when you have a system like you want to do some prediction, and in the background you need to make sure that your predictive model needs to adaptive in nature. So those are the things which is Stream has.
Okay, thank you very much. So thank you for accepting our interview request, and thank you for this video. I think anybody want to contact with you can email you from your email address alkan@ut.edu. Thank you very much.
Thank you.